Hello everyone, welcome back again. After understanding the line clipping algorithm, that is the Cohen Sutherland, and also understanding one of the example, let us move on to the next topic, that is the polygon fill area clipping. So now we understood how we can perform line clipping or a point clipping. Now what if we have a polygon and we need to perform the clipping? So when you are performing a clipping on the polygon fill area, you cannot apply the line clipping algorithm or the method because it doesn't because the whatever this approach you will apply it will not basically produce you a closed polyline, so that kind of algorithm is not applicable here. So how do you perform your polygon fill area clipping is basically stage by stage you have to perform clipping on this polygon. Just look at the image which is being specified here. So in this image, you have an original polygon, a star kind of polygon. So here the dotted line is basically representing the clipping window here. So our intention is whatever is within this clipping window, that alone needs to be displayed outside the clipping window. So whatever the parts we have here, the lines or the projection outside your clipping window, we don't want that to be displayed. So basically in our polygon fill area clipping, we go here by applying it across the stages. That is, we start from the left, right, bottom, and then the top. That is the stage by stage. So first left part, that is taking the left line as the reference, the polygon will be clipped. So if you observe here from the previous image here, only the parts of the polygon which are outside this left window is being clipped, others are untouched here, and this stage vertices of this stage is passed to the next stage, and this in the right stage whatever lines are towards the right of this right clipping window or the clipping line alone will be clipped. So in this way we pass it across every stages, and then we clip the polygon, and whatever is within the clipping window alone will be displayed. So here is another example of clipping a polygon. So here this is a triangle image or a triangle which is present here before clipping, but after clipping you have an image which is like this. So next we'll see how in application wise how we can apply this concept, that is the stage by stage clipping. So there's one algorithm which is helping us to perform this polygon clipping. It was developed by a person excuse me, by name Sutherland. So that's the name, that's the reason the algorithm is named behind these two people, Sutherland Hodgman polygon clipping algorithm. So again, as I told you, this basically works or takes stage by stage, and then it performs the clipping of the vertices, and then it passes the clipped vertices as input to the next stage, and a final vertex list will be prepared as to which are the vertices which has to be displayed. So this is how the clippers, we call these as the clippers, that is the left clipper, right, bottom, and the top clipper. So here there are some four possible cases which have been discussed here. We'll see one by one what these cases are. So what does this say? It says one possibility is that the first edge endpoint is outside the clipping boundary and the second endpoint is inside. So let's take an example like this. I'll just draw and I'll try to show you. So if this is say your assume this is your clipping window. So what is the possibility? It says the first edge endpoint is outside and the second endpoint is inside. So how does it look like is something like this. So just like our in the line clipping what we did, so first so your line is moving like this from the left towards the right, it is moving. So then I can say that this is the first end point and this is the second, because it is moving from right to sorry, from left to right. So the possibility here is that the first end point is outside the boundary, whereas the second end point is inside the boundary. Or the other case can be that both the endpoints are also inside your clipping boundary. This can be your second case, or the other way of your first case. That is, a line can be moving in this case where, so where your first endpoint is only inside but your second endpoint is outside. This can be one case, or it can be another case where both of your points are lying outside. That is this case. So this can be another case. So there are four possibilities. One is the first endpoint is outside, second point is inside, or first endpoint only inside, second is outside, or both the endpoints are inside, or both the endpoints are outside. So these are the four possible cases which we may be encountering while we are processing the edges within our polygon against all our clipping boundaries. So look into this example. So this example, if you understand clearly, it should be helping you to understand the algorithm. So this is a polygon which has four edges here. So here your dashed line is basically specifying your clipping window. Now if you start performing the that is if you start the clipper, the order if you will start is you will start from the left clipper onwards. So now I'll just try to take an example. Now see, this is your clipper. Say this is your line now. That is your left line. Now here, take this left line alone as reference. Forget your top lines and forget your bottom line and forget your right line. Just you assume that as though you have only your left line here now. So if you assume in that way, so to brief here, which all points are within the boundary is, I can easily say that V2 is within the boundary. I need not worry about it. And when I talk about a line, basically when I talk about a line V1 to V2, this V2 is inside. So this is a case wherein one first point is outside the boundary and second point is inside the boundary. So when I consider this line with respect to this left clipper, I can say that V1 is outside, so this should be clipped. So now I locate this V dash from here, I shift this V dash to this point here, and I call this as V dash of 1. This was with respect to your one clipper here, that is just the left clipper. And now here if you are assuming the top line here, they have not named anything here. So if you are taking this top line and trying to consider, so this top line, it is like the line is the polygon is moving in this way. I'll just draw and I'll show you. See, something like the polygon is like this, and then it goes from here to here, and then from here to here, and then from there it moves downwards. Maybe it is not very clear. Okay, so this is how it somehow looks like. Now here, this one, uh, line alone is what I have looked into with respect to this left clipper. So now this is only one left clipper which I have considered. Now I have to move from the left clipper, I have to move to the right clipper. So if I take the right clipper, it will be in this way. And after that right clipper, I have to move to the top bottom. So in this way we are processing the edges from each that is from the left, right, top, bottom. We are just processing the edges and seeing which is available to your next image. So just take this example. So this is a triangle now. Clipping window is shown with dotted lines. So there are only three vertices initially. We take them as 1, 2 and 3. So let's start with the left clipper. Now I told you when we start with the left clipper, so this is my left clipper, this dotted line. Okay. So you need not worry about the other three, that is, you need not you need not worry about the right, top and the bottom clippers here. First see how your left clipper is working. So now see, this is your one line here. Extend this left clipper. So at what all points this left clipper will basically the region which intersects here we'll see. So first we'll see the line 1 2. So if you see the line 1 2, it is not at all outside the boundary when you're talking about the left clipper. So this is a case of in to in, that is from the inner boundary to the inner boundary only. So this is nowhere we have to say clip our point. And the next is consider the line 2 to 3. See, your line is moving in this way: 1 to 2, 2 to 3 and 3 to 1. This is the order of your vertices. And when you take 2 to 3 here, so what does this say? Where with respect to the left clipper I am talking. So from 2 to 3, if you take, this is a case of 2 is inside and 3 is outside. That is what is specified here, into out. So here what are we doing is the output of this is a new point called as 2 dash. So but in the previous case we didn't do that. 1 to 2 we didn't create any new vertex, we kept 2 only as the output vertex. But here 3 is not the output vertex, you have shifted 3 to another point and you have called this as 2 dash. And next the line 3 to 1. So 3 to 1 is a case of out to in. That is what is specified here, out to in. And again here this 3 is been that is shifted, or this 3 has a new position called as 3 dash. This is the output of this particular line 3 comma 1. So in this way we have to perform it for all the clippers. I will take an example or the same example with another, and step by step I'll prepare a video and I will send it that is the next video I will be sending. So this was just the explanation of how the Sutherland Hodgman algorithm works, and this is very important. You can expect at least one problem or explanation of the algorithm. So the next video I'll take a step-by-step example, a written notes kind of, and I will record a video and send you. So as of now, please solve the previous Sutherland problem which I had sent, and also understand this Sutherland Hodgman algorithm. Thank you everyone.